Hello and welcome. Today we're going to talk about solving linear equations. These are equations which involve the variable x or any other variable, but what's important is there's only one of them and it's to a single power. So not x squared, not x cubed, no log of x, no e to the x, and so on. Just nice, simple x. Now, what is our goal when solving a linear equation? The goal for solving is to find the variable, to get the variable alone. So the way in which we're going to do this is actually to focus on our variable, do the reverse of PEMDAS, if you guys remember PEMDAS, and isolate it that way. And in doing so, we're always going to work from the outside in. In the earlier examples, that won't matter too much, but you'll see why it's important later on. So let's try a couple out. In this first example, we have x plus 5 equals 12. Not too crazy. Our goal is to get x alone. The 5 is a problem. Notice the 12 doesn't matter. 12 is hanging out on the other side of the equal sign. It's not giving any trouble to the x. The issue is this 5. And so we're going to deal with it. I'm going to think, what's the opposite of a plus 5? And that's exactly what I'm going to do. The opposite of adding 5 is subtracting 5. So I'm going to subtract 5 to both sides. And with that, I get x is equal to 7. And that's my answer to the first question. Now, moving on, let's go over here. We have 2x minus 3 is equal to 7. So there's a little more going on here. Once again, on the right side, this 7 is not an issue because the x is not being affected by it. My goal is to get x alone, so I identify the two problems we have. We have a negative 3 and we have a 2. Those are both hanging around the x and we have to get rid of them. So the question is, which one am I going to deal with first? So in order to solve this problem, because it's a little more complicated, we're going to refer over to our PEMDAS. I'm going to do the opposite of it. When we look here, I need to decide because I have two problems. I have this negative 3 hanging around. I have this 2 hanging around. I need to decide which one to get rid of first. Do I divide by 2 or do I plus 3? Well, I'm going to go over to PEMDAS and I'm going to go backwards from S to P and says, deal with subtraction and addition first. And so I'm going to do that. I'm going to deal with this minus 3. So I plus 3 to both sides, plus 3, plus 3. I get that 2x is equal to 10. And then I only have one thing left to deal with, and that's 2. And I'm going to do the opposite of it. So if we're multiplying by 2, the opposite is to divide by that 2. And we're going to do both sides. And that gives us that x is equal to 5. And that's our answer. So once again, we had to decide which to deal with, the minus 3 or the 2. We dealt with the 3 first because addition and subtraction is the last in PEMDAS, reverse PEMDAS. Let's see some more examples of this. Now, in the bottom left, we have 3x plus 2 is equal to x plus 8. This is a little interesting because we have multiple x's involved. We have 3x over here and regular x over here. So before I go through my sequence and start isolating x, I need to bring all the x's together. I can either minus 3x to both sides or minus x to both sides to move it around. I'm going to do a minus x to both sides because I don't like having negatives. And this will give me a positive 2x. Plus 2 equals positive 8. Now, I go through my sequence. What am I going to do? I need to get x alone. Am I going to deal with the plus 2 or the times 2 first? According to the reverse of PEMDAS, I need to deal with the addition and subtraction first. So I'm going to deal with that plus 2. I'm going to do so by doing the opposite of it. The opposite of plus 2 is a minus 2 to both sides. And I get 2x is equal to 6. Furthermore, I need to get rid of that 2. It's the only thing left, so I don't have to worry about PEMDAS. And I know that the opposite of multiplying by 2 is dividing by 2. And so finally, I get that x is equal to 3 for my answer. Let's go for another one. Over here, we have some distribution going on. We have 2 times x minus 4 is equal to 3x plus 1. There's a few ways to deal with this. You can either divide by 2 on both sides or distribute it to both. I think dividing by 2 would get kind of ugly. So I'm just going to distribute this in right away. So I don't have to deal with that. I get 2x minus 8 is equal to 3x plus 1. Now, once again, I don't have all the x's together, so I can't go through my sequence. And so I'm going to either move this 2x to the right or this 3x to the left. I'm going to start with the 2x minus 2x minus 2x because I don't want negatives. If I minus 3x, I get negatives. This leaves me with a negative 8 equals x plus 1. Now I need to get x alone. There's only one thing next to it, so I don't have to care about PEMDAS. And so I'm just going to do the opposite of that, whatever operation is happening. The opposite of a plus 1 is a minus 1 to both sides. And in the end, I get that x is equal to negative 9. And that's my answer. Let's try some more challenging problems. Over here, we have some fractions going on, which may be annoying, but doesn't change our goal, or our strategy. Our goal is still to get x alone, and our strategy is to move all the x's together and then isolate using the reverse of PEMDAS. In this case, I have a nice little trick for dealing with fractions. If you don't like fractions, you can actually just not deal with them. How is that? Well, I notice this is a 1/2 and this is a 1/4, and I think, how can I get rid of both of those? It'd be nice if I was multiplying by 4 on everything, because then the 1/2 and the 1/4 would turn into regular numbers. And I'm going to do exactly that. I'm going to times everything by 4. And I'm allowed to do that because it's happening to both sides. Now I have to distribute that 4 to everything, including the 3 and the 7. So when I get 4 times 1/2, that leaves me with the 2x. 4 times 3 is a plus 12. 4 times 1/4 is just 1. And so I'm left with a singular x, 1x. And then 4 times 7 is going to be 28. And so now I have the same equation, but with no fractions happening, which is really convenient. Now I could focus on bringing all my x's together to the same side. I'm going to do that by minusing an x on both sides. Again, if I did a minus 2x, I'd have a negative x variable, which is pretty annoying. We're going to avoid that. This leaves me with x plus 12 is equal to 28. And then I can minus 12 on both sides because there's only one item and I just do the opposite of it to move it around. The opposite of plus 12 is a minus 12, minus 12. And in the end, I get that x is equal to positive 16. Now we're going to see what happens when x is in the denominator. Previously we had fractions, but the fractions had regular numbers in the denominator. Now x is kind of stuck down here. And so often students will see this and they'll think, well, do I need a minus 4? Do I need times 5? You have to get x from out of under the denominator before you can do anything really. It's stuck down there and it's very annoying. So how would we do that? Well, the easiest way is times both sides by the denominator. So I'm doing x plus 4 on the left side times an x plus 4 on the right side. What this does on the left side is, because this is in the denominator, x plus 4 divided by x plus 4 cancels out and we're left with 1. And so that 5 sticks around on the left side. And on the right side, we have 10 times x plus 4. Now we need to continue trying to isolate x. Oh, there's a distribution. I can just distribute. So I get 5 is equal to 10x plus 40. And then I can work to isolate x by removing the 40 and the 10. The question is, which one comes first? Well, once again, if I were to write PEMDAS over here, PEMDAS, I'm going to work backwards and think, well, the first things I have to deal with are addition and subtraction. So I'm going to deal with this plus 40 by minusing it, doing the opposite, minus 40, minus 40. This will give me that negative 35 is equal to 10x. Now, this is not going to leave a pretty number. But what I'm going to do is get rid of the 10 by doing the opposite of 10 times, which is to divide by 10. I'm going to divide by 10 on both sides. And what I'm left with is that x is equal to negative 3.5. 35 over 10 is 3.5, and we let the negative hang out. And that's our solution for this. These last two problems are going to be outliers. I'm going to see that they have interesting solutions going on. Let's look at this one. We have 2x plus 1 is equal to 2x minus 3. In this case, we have a 2x on the left and the 2x on the right. Now, normally, our goal is to bring all the x's together to start before we go through our sequence, reverse PEMDAS, and all that. But when we do that, if I minus 2x to both sides, minus 2x over here, what I'm left with is 1 is equal to negative 3. So when they have the same constant next to the variable, same coefficient, something interesting happens. All the x's go away. So what does this mean? What would we say? Well, does 1 ever equal negative 3? Is that ever true? No. So our answer for this is in fact going to be no solution. There is no solution to this. Now, the reason for that, what this looks like, is essentially they're parallel lines. So one's going like this, one's going like this, and they never cross. But all you need to know is that if you end up with an incorrect statement, an incorrect equal sign, and in your solving of an equation, you write no solution. For this one, we have 4x minus 2 is equal to 4 times the quantity x minus 1/2. Now, like usual, I see a distribution. I'm just going to distribute, make life easier. So I have 4x minus 2 is equal to 4 times x minus 4 times 1/2 is going to give us just a 2. Oh, that's kind of interesting. They're the same on both sides. What does that mean? Well, let's see. I'll do like normal. Bring all the x's to the same side so you can isolate later on. But when I do that, minus 4x, I'm left with negative 2 is equal to negative 2. And there's no x's involved. So what do I say for this? How do I answer? Well, is negative 2 equal to negative 2? Yes. What if x was a billion? Would negative 2 still equal negative 2? Yes. Whether x is 1, 5, a million, a billion, or a smiley face, negative 2 is in fact equal to negative 2. So this is always true. And when you get something that is always true when you're solving for the equation, you would write infinite solutions. So this problem has infinite solutions. It is always the case that this equation will hold true because this is in fact the same line on top of itself. 4x minus 2 looks like this maybe. And then the other 4x minus 2 on the right side is just laid right on top of it. So they are always overlapping, they are always intersecting, and every answer for x is a valid answer. Okay, so as a recap, your goal for these equations is to get x alone. That's your goal. And how are we going to do that? Well, number one, we're going to get all of the x's together. Once all the x's have been brought together, then you can start acting to isolate. In order to decide what to get rid of and isolate, you're going to use the reverse of PEMDAS. So when reading PEMDAS backwards, it tells you what to deal with first. You're going to deal with addition and subtraction before you deal with multiplication and division, before you deal with parentheses and exponents. Lastly, when you've decided what you need to get rid of, you need to perform the opposite operation. Whatever the opposite is of what's happening, you need to perform that. So a couple of quick reminders. If you have 3 times x, the opposite of that is going to be a division by 3. If you have an x plus 7, the opposite of that is going to be a minus 7, and so on. With this system, you can easily solve any linear equation and get x alone without much headache.